there. We looked today in class at switching back and forth between different linear forms, as well as identifying ordered pairs and slopes from given equations. And so your Unit 3.5b worksheet is broken up into 8 problems, and the top 4 correspond to the bottom 4. And so we're going to go ahead and look at a couple of these top ones, just so you can see some of the steps. These also line up with the notes that we took in class that I have uploaded to my website, giving some of the steps for switching back and forth between different forms. If you're able to get an equation in point-slope form, how can you turn it into slope-intercept or into standard? Or if you can get an equation in slope-intercept form, how do you turn it into point-slope or standard? And then, of course, getting it into standard, turning it into the other two. Okay, so taking a look here at our worksheet, we start with our point-slope form, which is y minus 4 equals 5 times the quantity of x minus 8. And they ask us to turn it into slope-intercept form, standard form, and identify ordered pairs and slope. Okay? And so I'm actually going to start with this last box first, because the nice thing about point-slope form is it's true to its name. You have the point and you have the slope inside your equation. Okay? The point is always the x and y, or the numbers I should say. The point is always the numbers attached to the x and the y, and they're always the numbers behind the minus, right? And so in this case, the x coordinate of my point is 8, because that's what's behind that minus. And my y coordinate is 4, because that's what's behind that minus. And then my slope in this particular equation would be what's located outside the quantity, outside the parentheses, and that would be 5. Okay. To turn a point-slope form equation into slope-intercept, we first need to start with distributing. Because when you look at point-slope, which is this form, and you look at slope-intercept, which is this form, y equals mx plus b, one of the first things you realize is there are no parentheses in slope-intercept form. And so to get rid of those parentheses, we're going to distribute that 5n. So when I do that, I get y minus 4 equals 5x minus 40, because 5 times x is 5x, 5 times 8 is 40. Okay, and then looking at slope-intercept form, the other thing we take note of, comparing the two, is that while point-slope has a number with the y over here, slope-intercept does not. And so I need to somehow get rid of this minus 4, and so to undo minus 4, you're going to add 4, and add that 4 over here. And so then we'll get y equals my 5x, right? Y equals 5x, and minus 40 plus 4 is minus 36, or negative 40 plus 4 is negative 36. Okay, so it's turning it from point-slope into slope-intercept. Okay. In standard form, when you look at the standard form, we see ax plus by equals c. And looking between slope-intercept and standard, the thing that I notice is that my x and my y in standard are on the same side of the equals. Over here in slope-intercept, I have y on one side and 5x on the other. And so I want to get this 5x over here with the y. That way it looks like standard form. The other thing you want to keep in mind about standard form is standard form, a, b, and c are all integers. None of them are fractions. And so if for some reason I had a fraction in my slope-intercept form, I would want to get rid of that fraction by multiplying every term by that denominator. When you multiply every term by the denominator, that would turn your fraction into an integer. It's not going to pertain to this particular problem, but that is a step you would want to keep in mind. Okay? So to get this 5x over to the same side as the y, I'm going to do the opposite, which is subtracting 5x. And so we get negative 5x plus y equals negative 36. Negative 5x plus y equals negative 36. Okay. In number 2, we are given an equation in slope-intercept form, and we are given an ordered pair, a point. So first let's go ahead and identify what is our slope. In slope-intercept form, your slope is the number attached to the x. And I can't see it, but it is there. That number attached to the x is 1. And so my slope in this case is 1. Okay. We already talked about how to turn slope-intercept into standard form. We did that up above. We need to get the x over on the same side as the y. And so we'd have negative x plus y equals negative 4. It's the same step we did up here. Okay. So let's go ahead and focus in then on that point-slope form. Point-slope form, true to its name, you need a point and you need a slope. Well, we've got that. We were given a point and our slope was located right here next to my x. And so all I'm going to do is file that into my point-slope form. Point-slope form is y minus y1 equals m times x minus x1. Okay. Well, my y1 in this particular case was negative 2. My slope was 1. And my x1 is 2. And if you wanted to clean this equation up a little bit, minus a negative is the same thing as positive. And technically I don't need that 1 there, right? 1 times the quantity is the same thing as just writing the x minus 2. 1 times a number doesn't change it. But if it makes you more comfortable, it would be fine if you left the 1 in there, even if you don't technically need it. Okay. Number 3 here, our standard form. We are given 2x minus 3y equals 6, and we are given an ordered pair, 9, 4. In this particular one, we aren't going to start with slope, because standard form inherently, like when you're just looking at the equation, doesn't have slope. Remember, standard form was ax plus by equals c. No m, no slope. I can figure out intercepts from it, x and y intercept, but I can't figure out slope. So to get my slope, eventually, I'm going to need to first turn it into one of these two other forms. And in my opinion, the easiest one to get standard form into is the slope-intercept, because we're just going back the other direction. What we've already done up above, turning slope-intercept into standard, we're going to go the opposite way. Okay. So looking at standard form here, comparing it to slope-intercept, the first thing I notice is that y and x are on opposite sides in slope-intercept. And so that's where I'm going to start. I want to get rid of this 2x. I want to bring it over to the other side. And so I'm going to go ahead and subtract 2x over here. So we're left with negative 3y equals negative 2x plus 6. Okay. So now my x and y are on opposite sides. Check. The other thing I noticed about slope-intercept is that y is all by itself. There's no number with y. Okay. When I'm looking at where I'm currently in this problem, I notice I have a negative 3 attached to that y. I can't have a negative 3. So I need to get rid of that. When a number is sitting right next to a letter like that, that means multiplication. And so to undo multiplication, we are going to divide. Excuse me. Okay? And if you're going to do it to one term, you do need to make sure you've done it to every other term as well, maintaining equality. Okay, so slope-intercept form, we're left with y equals negative 2 divided by negative 3 is 2/3, and positive 6 divided by negative 3 is negative 2. And now I can find my slope. I did that already in number 2. When I'm looking at slope-intercept and I want my slope, it's the number right next to the x, which in this problem is 2/3. Okay, and now it's the same thing we did in number 2. I have a slope, I have a point. I can put it in my point-slope form. Y minus my y1 equals my slope, which is 2/3, x minus my x1. Okay. And then the final one we're going to look at here is number 4. Number 4 actually, as you'll see in a bit, is very, very, very similar to number 1, or will end up being, I should say, it'll end up becoming very, very similar to number 1. But we need to start with reviewing something back from 3.1, which was how do you find a slope from 2 points? Because that's all I'm given in number 4. I'm given 4, -2, and 5, -4. Okay. To find the slope between 2 points, you subtract your 2 y's, so -4 minus the -2, and then over subtract your 2 x's. Okay. And to find that slope, it doesn't matter for your y's which one you subtract first. You could do -2 minus -4 or -4 minus -2. Doesn't matter. But whichever one you choose to use first, in this case I chose to use -4 first. Whichever one you choose to use first, make sure you use its x first as well. So if you notice, I used -4 first, and so I used 5 first as well. -2 came second, so 4 came second as well. Right, your x and y will always stay kind of paired up, one underneath the other. -4 minus -2 minus a negative is the same thing as positive. -4 plus 2 is -2. 5 minus 4 is 1, and -2 divided by 1 is -2. Okay. At this point, you've got your slope, and you've got a point. You actually have 2 points, and so we can very easily turn it into point-slope form. It doesn't matter which point you use. You pick one of them. Okay. And so we have our y minus, if I used this point, it would be -4 equals my m x minus my x1, which is the same thing if you clean this up as y plus 4 equals -2x minus 5. Or you could use the other point, which would be y minus -2 equals -2x minus 4, which if you clean this up is the same thing as y plus 2 equals -2x minus 4. Either one of those equations would be right. And at this point, now that you're in point slope, you have either point slope equation. Again, does not matter, either point slope equation. You're doing the same steps now that we did in number 1. To turn it into slope-intercept, you'll distribute and then subtract over. And then to turn into standard form, you'll make sure that your x's and y's are on the same side of the equal sign and that there are no fractions. Okay. And that was 3.5b.